We're going to look at a related rate problem, and this is example number 4 from the packet in class. Water is flowing into a cone with a height of 16 centimeters and a radius of 4 centimeters at a rate of 2 centimeters cubed per minute. How fast is the water level rising when it is 15 centimeters deep? First thing we want to keep in mind for this problem is the volume of a cone. Volume of cone is V equals 1/3 pi r squared h. Well, right now when we look at that equation, we have 3 variables, v, r, and h. And if I were to take the derivative right now, I would need to use the product rule. We could do that, but let's list out all of our information first. How fast is the water level rising? That is dH dt, and that is what we are trying to find in this problem. Now, we also have that the height at the end is going to be 15. We won't be using that until after we've taken the derivative. And we have dV dt is 2 cubic centimeters per minute. So, right off the bat, when I make this list of my information, you notice there is no dr dt. Well, how are we going to deal with that? We could actually use similar triangles. So here I have one triangle that I have r and h, and then I have another triangle here, and they're similar by angle. They share that common angle at the peak of the cone, and they both have right angles there, and they share a common angle at the base as well. So here we have 4/16, radius over height, has to equal radius over height. What I can do here is cross multiply and have 4h is equal to 16r, and r is equal to h over 4. I'm solving for r because I want to eliminate that variable. Now if I go back to my equation, I can have v equals 1/3 pi, then instead of r squared, I can rewrite that as h over 4, quantity squared. So now I've got v equals 1/3 pi h over 16, h squared over 16, times another h. So what I'm doing here, I get pi over 48 h cubed. Now I have my equation for volume of a cone solely in terms of its height. I can take the derivative on both sides, and I get dV dt on the left is equal to pi over 16. I bring down the 3 48 is 1/16, h squared dH dt. Don't forget to have that dH dt because we're using the chain rule here. And we're not taking the derivative with respect to h, we're taking the derivative with respect to t. So, now that we've taken the derivative, we can plug back in. We're going to have 2 equals pi over 16, 15 squared dH dt. 2 equals pi over 16 times 225. Multiply by the reciprocal to get dH dt is equal to 32 over 225 pi. You can put that in your calculator to find a decimal approximation if you'd like, but I'm going to leave it just like that. Centimeters per minute. And that concludes problem 4.